So on to acid-base equilibria. When we're comparing in a reaction, the equilibrium constant for a generic reaction is calculated based on the Ka values of the original reactant acid versus the product. This is also called the conjugate acid. And I want you to remember that the conjugate acid is formed from the base. Remember, the acid reacts with a base, and the acid makes a conjugate base, and the base makes a conjugate acid. So we're going to look at the Ka of the original acid and the conjugate acid and compare them. So the Ka of the reactant acid over the Ka of the product conjugate acid, we're going to compare them to get an equilibrium constant. The reaction is going to favor the product, so it's going to be driven towards a product when our K is greater than 1. That means that the Ka of the reactant, the acid, is stronger, it's bigger than the conjugate acid that forms. That's the situation we want in which to drive it towards the products. If it's the opposite, if the starting acid has a small Ka and the final conjugate acid has a big Ka, we'll actually drive it the other way. Let's see an example of this so you can kind of see. Here is water reacting with hydrogen bromide to form hydronium ion and bromide. And I've actually shown you the pKa's here, okay? The pKa, remember pKa is different in terms of Ka. pKa for hydrogen bromide is negative 5.8. That means it is strong. This is the acid. Okay, remember the acid forms the conjugate base, and the base forms the conjugate acid. So we're going to compare the acid to the conjugate acid. The conjugate acid in this case is hydronium ion, and its pKa is 0. It's weaker. So always the reaction is going to drive in the direction where the stronger acid is on the reactant towards the weaker acid as the product. This is kind of, in terms, sounds confusing, but ultimately it makes sense. The stronger acid wants to dissociate. It wants to just become product. So if you have the stronger acid on the reactant side, it will drive in that direction. It wants to dissociate. Weaker acids are not good at dissociating. They're not good at being an acid and donating protons, so they will stay in their form. Here's another example. We have water reacting with acetic acid. That is our acid, of course. Its pKa is 4.7. Now, water is our base. Acetic acid is the acid. So acetic acid, you can see its product over here, the acetate ion. That is going to be our conjugate base. And the hydronium ion is going to be our conjugate acid. Hydronium ion's pKa is 0. That's not very big, but when you compare, hydronium ion pKa is smaller than acetic acid pKa, which is 4.7. So hydronium ion in this case is actually the stronger acid. And so in this case, our equilibrium will go in the opposite direction. It will go towards the weaker acid, from the stronger to the weaker acid.